Okay, in this video we're going to look at quadratic equations and their graphs. Okay, basically saying how are quadratic functions related to their graphs, and how the factored form relates to the graph, okay, and all these different connections. So number one, we're given y equals x minus 4 times x plus 2. We're going to express the equation in standard form, make a table, and graph the equation. Okay, so in standard form means we're going to FOIL this out. Okay, right now it's in its factored form. Okay, so in standard form, if you multiply this out, x times x is x squared. Okay, and then we'd have x times 2 is 2x, and then minus 4x would give us negative 2x as middle term, and then negative 4 times 2 is minus 8. Okay, so there is the standard form. Okay, now if we were to make a table, okay, for x and y, one thing we can always do is go to a calculator. And if we press table in the calculator, now mine's already in there, but I'll show you. If to put x squared in, you do the x variable key, so x, and then squared is right above that, and then minus 2x, and then minus 8. Now you could also enter as the factored form if you wanted to. Okay, it's up to you. Okay, press enter, and it takes you to your table. Now mine just says start at 4, step 1. What that means is if I were to go to the table now, it would start at a value of 4 and go up by 1s. Okay, then you can scroll up and down in the table. So I'm just going to go down to OK by using the arrow key, press enter. See, it's starting at 4 and going up by 1s. Now you notice that when I get to 6, I'm already at 16, which I'll be off the grid over here. So I want to scroll up some and think about, okay, what numbers can I put in there that are going to give me nice answers? Well, by the time I get to negative 4, I go to positive 16, which is off the grid. So I'll start at negative 3, and y is 7, and then x is negative 2, y is 0, and so on. So my table of values will start at negative 3. Negative 2, negative 1, 0, 1, 2, 3. Okay, now if I keep scrolling down, though, notice that at 4 I get 0, at 5 I get 7. Okay, so I'll put those values in the table also. Then when I get to 6, I'm at 16. Okay, so if I fill those values in, okay, you can do this on your table in your calculator. Okay, then you want to plot the points. Okay, so we're going to plot the points negative 3, 7. So 1, 2, 3, and then up 7, 2, 3, 4, 5, 6, 7. So there's a point, and then negative 2, 0, there's a point, okay, and so on. Now I already have this graph for the sake of time. Okay, so if you need to pause the video, go ahead. Okay, by the time you're done, though, you should have that nice parabola, okay, that nice U shape, like that. Okay, then it asks you, what are the X-intercepts and what is the Y-intercept? Well, we can see the X-intercepts are at this point and this point. So they're at negative 2, 0 and 4, 0. Okay, so negative 2, 0 and 4, 0. Now, part of what the idea here is with the quadratic equations and their graphs is to see the relationships going on here. Okay, notice that negative 2, 0 and 4, 0, okay, those two x values, if you go to your factored form, notice that when x equals negative 2, that negative 2 plus 2 gives you 0. So that means when x equals negative 2, y equals 0, which gives us this x-intercept. And notice when x equals 4, 4 minus 4 will give you 0, which again gives you the x-intercept at 4, 0. Okay, so notice that the x-intercepts are where the factors, x minus 4 and x plus 2, okay, those were the factors. Okay, that is where those factors equal 0 at positive 4 and negative 2. Okay, then the y-intercept, okay, to find that, The y-intercept, we can look at our graph and see that it's down here at 0, -8. Okay, and we can see that in our table here also at 0, -8. But easier than that, we can look at our standard form, and remember that for the y-intercept, okay, on the y-axis, the x value is always 0. So if you look at 0 squared minus 2 times 0 minus 8, the x squared and 2x would go to 0, and then minus 8 would give you -8. Okay, so the y-intercept is 0, -8. So the x-intercepts are easy to find when you have the factored form, and the y-intercept is easier to find in the standard form. It's basically your c value. Okay, also notice with the x-intercepts, that is when the y value is 0 in your table. Okay, that happens at -2 and +4. The y-intercept is when the x value is 0, so it's 0, -8. Okay, some new terminology, vertex and axis of symmetry. The vertex is the maximum or minimum point on a quadratic function. Okay, or you can look at it as the highest or lowest point on a quadratic function. So what are the coordinates of the vertex of y equals x squared minus 2x minus 8? Okay, so that's the equation we have up here. There's a standard form and there's the factored form. Okay, so the coordinates of that vertex, well, the lowest point occurs right here, which is at 1, -9. Okay, so the vertex is at 1, -9. Now the axis of symmetry of a quadratic function is the line dividing the graph into two symmetric or mirror images. Okay, so basically the line that cuts the U shape in half. That's one way to look at it for a parabola. So if we draw a line straight down the center here, okay, right through here, well, the equation of that line, notice that the x value is always 1 on this line, so x equals 1 will be the axis of symmetry. Okay, notice a couple things. Notice that the axis of symmetry goes through the vertex. Okay, it passes through the vertex. So notice that the x value on the vertex was 1. Okay, that'll always happen on a parabola like this. Okay, and then also notice that the AOS, okay, I use that for short for axis of symmetry, is halfway between the x-intercepts. So if you take halfway between -2 and +4, well, that's a total distance of 6. If you divide that by 2, that's a distance of 3. So if you go 3 in either direction, from the left-hand side, if you go +3, we end up right here. If you take away 3 from the x equals 4, 1, 2, 3 this way is right here. So that x value, x equals 1, is the center of the graph, which is the axis of symmetry. Okay, now I say the x-intercept's halfway between those, but it's really true for any two symmetric points. If we took these 2 points right here, this point and this point, halfway between them is right here. Because it's 1, 2, 3, 4 away from this point, and 1, 2, 3, 4 away from this point. If you look at the 2 points down here, it's only 1 away from each of those points. Okay, so basically what you do is, if you have two symmetric points, okay, symmetric points meaning they have the same height on the graph, the same y value. Okay, so these 2 points, the x-intercepts, these 2 points. If you add the two x values together and divide by 2, basically find the average of the two x values, that'll give you the axis of symmetry. Okay, so number 2, just kind of emphasizing that concept. Find the x-intercepts and the axis of symmetry for each function. So if you have x plus 7 times x minus 5, the x-intercepts will be at -7, 0, and 5, 0. Okay, and again, the basic idea there is that you're setting your equation equal to 0. So to get 0 for y, you have to have -7 or +5 for x. Okay, and then to find the axis of symmetry on these, you have to find what value is halfway between -7 and 5. Well, to find that, you add -7 and 5, and then divide by 2. So x equals -1, because that's -2 divided by 2. So x equals -1 will be the axis of symmetry. And don't just say -1, make sure you put it as an equation, because the axis of symmetry is a line that goes through the center of your parabola, or cuts it in half. into two mirror images. Okay, it's always a line x equals. Okay, so in this case, x equals -1. Okay, so same concept if you try B and C. Okay, if you want to pause the video, you can, and I'll put the answers up. Okay, these one, the algebra is a little bit not as nice, or a little bit trickier, but you can still handle that using your calculator. Okay, so moving on to the next page. Okay, the next group of questions is just looking at solving the quadratic equation and then seeing how the x-intercepts are related to those and the vertex and the axis of symmetry. So just a little bit of practice with that. Okay, so number 1, you're given f of x equals x squared minus 4x plus 3. And I saved you time by graphing it for you. Now I would expect you to be able to graph this, whether you use a table on your own or go to your calculator and plot the points. Okay, that's up to you. Okay, but when you go through and solve x squared minus 4x plus 3 equal to 0 by factoring or applying the quadratic formula, well, this one, does anything multiply to 3 and add to -4? Well, if we do x minus 3 and x minus 1 equals 0, and then we get the solutions of 3 and 1. And notice that 3 and 1 are the x-intercepts. Okay, so that's a very important connection to make. Okay, so here, one of the basic ideas is that if you know the x-intercepts, then you should be able to find the equation also. Because if you know that x equals 3 is an x-intercept or a solution to your quadratic function, then x minus 3 had to be a factor. If you know that x equals 1 is a solution, then x minus 1 had to be a factor. Okay, part B, I want you to find the equation for the axis of symmetry. Now what we're going to transition into is, rather than just look at it on the graph and say, okay, we can see that the line that cuts the parabola here in half looks like is right here, so it looks like it should be x equals 2. Okay, rather than going to a graph and looking at that, we can also look at x equals negative b over 2a. Now you might recognize x equals negative b over 2a as part of the quadratic formula. When you do x equals negative b plus or minus the square root of b squared minus 4ac, when you put that all over 2a, you can also look at it as breaking the fraction apart into two separate fractions. Okay, for example, if you had 5 over 2 plus 3 over 2, wasn't that the same thing as 5 plus 3 all divided by 2? All we're doing here is we're going backwards here. So if we're 5 plus 3 over 2, we're looking at that as 5 over 2 plus 3 over 2. Okay, 5 over 2 plus 3 over 2. Same idea with the quadratic formula. If you break it apart like this into two fractions, notice that x equals negative b over 2a is the first part of that. Now we're not going to get too much into this, but just a very quick explanation of what's going on here. That negative b over 2a gives you the center of your parabola. The square root of b squared minus 4ac over 2a, what that really represents, I know it seems kind of weird, okay, and it's like, well, what's he talking about? But the square root of b squared minus 4ac over 2a, what that'll represent is the distance that you're going to add and subtract from the center to get to the x-intercepts. So if we were to use the quadratic formula on this, negative b would be positive 4, because negative 4, plus or minus the square root of negative 4 squared minus 4 times 3 times, 4 times 1 times 3. I just have them backwards, sorry. Okay, 4ac will be 4 times 1 times 3, all over 2a. Well, a is 1, so that's 2 times 1. So x equals 4 plus or minus the square root of 16 minus 12 will give you 4, all divided by 2. Now I'm going to write it this way, though. I'm going to divide both by 2. So x equals 4 over 2 is 2. So x equals 2, that's this piece. That's the quadratic, that's the axis of symmetry, x equals 2. And then plus or minus, well, the square root of 4 is 2, divide by 2. So that'll be x equals 2 plus or minus 1. So that 1 is what you add to 2 to get to your x-intercepts. You add 2 plus 1 to get 3, and then subtract 1. 2 minus 1 gives you 1. So that square root of b squared minus 4ac all over 2a, that piece right here is the distance that you're going to go from the center of your parabola to get to the x-intercepts. So it's kind of a neat thing to hopefully understand that. Now I'm not going to test you on that as far as explaining what that square root part means, but that's really what it is. Okay, so axis of symmetry, x equals negative b over 2a, will be the negative negative 4 over 2 times 1, which is 4 over 2, which we said is 2. So the equation is x equals 2. Okay, part C, the coordinates of the vertex. Well, to find the vertex, we're trying to find what point, x, y. Okay, remember the coordinates means you're looking at x comma y, you're looking at a point. Well, we know the x value is 2. What's the y value? Well, the y value is going to be whatever your function value is at the axis of symmetry, negative b over 2a. So you're going to put that value in, negative b over 2a, into your function. Well, we know that negative b over 2a gives us 2. So we're going to find f of 2 equals 2 squared minus 4 times 2 plus 3. Okay, we're just going to use our original function up here. Okay, and when we do that, we end up with negative 1 for the solution. Okay, so the vertex is at 2 comma negative 1. Okay, if you go through and do number 2, okay, do the same idea. I'm just going to put the answer up though for the sake of time. Okay, I'm not going to explain everything as in depth as I did in the first one. Okay, but it's the same question, just a different function now. Okay, so pause the video and I'll put the answer up. Okay, this one, it doesn't work out quite as nice with the arithmetic, but again, use your calculator and you won't miss it. Okay, make sure you put negative 5 halves, make sure you put parentheses when you substitute in place of x. Okay, especially when you have a negative there, because it'll give you the wrong sign otherwise, and the wrong answer. Okay, so nothing too much to say on that one. That one factors x plus 6 and x minus 1. Okay, that's a factoring a lot of people miss. They'll put like 3's and 2's in there. But what multiplies the negative 6 and adds the positive 5? Well, positive 6 and negative 1. Okay, and again, notice that negative 6 and positive 1, your solutions to that equation, are your x-intercepts, negative 6 and positive 1. Okay, that's a very big connection to make. So if we know that x equals negative 6 is a solution, then x plus 6 had to be a factor. If x equals 1 is a solution, then x minus 1 had to be a factor. Okay, then moving on to the last page here, number 3. Okay, again, same question except a different function. What you might notice on this when you look at the graph, notice that it looks like the x-intercepts are not really nice numbers. So what that probably means is, it probably means it doesn't vector very nicely. Okay, so there's nothing that multiplies the negative 2 and adds the 6. So that means you're going to have to use the quadratic formula for this one. Now, I say round your answer to the nearest hundredth just so you can check them to make sure that it looks like they're approximately where they're supposed to be. So you should get negative 6 point something and positive point something. Okay, so take a minute and do that. And again, I'm just going to put the answers up. Okay, so pause the video if you need to. Okay, so here we end up with a square root of 44 in our answer, which is not a nice perfect square. And if you do this in the nearest hundredth, we get positive 0.32 and negative 6.32, which does match up with your x-intercepts right here and over here. The axis of symmetry, doing x equals negative b over 2a, so negative 6 over 2 times 1 gives you x equals negative 3. And then to find the vertex, substitute that back into your function, and we get negative 3 comma negative 11 for the vertex, which does match up with the graph. Okay, and the idea here is make sure that because you're given the graph, make sure that your answers are matching up with what's happening on the graph. The axis of symmetry at negative 3, that looks good. Okay, it goes right through negative 3 right there. And then negative 3, negative 11, that point is the vertex. Okay, then moving along to the last one. Okay, again, if you go through and do the solving that equation, x squared plus 5x plus 7 equals 0. Does anything multiply to 7 and add to 5? Well, no, because 1 and 7 will not add to 5. So when you use the quadratic formula on that, okay, what you may notice is you end up with a square root of a negative number. So a square root of negative 3 is a non-real solution. Now the thing to understand in this one is, notice what's happening with the parabola. We have a non-real solution for the x-intercepts, and notice your graph does not cross the x-axis. So when you have a graph that does not go through the x-axis, you're going to have a non-real solution for your quadratic formula. Okay, and then the axis of symmetry. Well, if you do x equals negative b over 2a, that'll be negative 5 over 2 times 1, which gives you negative 5 halves. Okay, and then the coordinates of the vertex, substitute that negative 5 halves into your function.